This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. Did you know that Sherloc is on Mars? Okay, not the Sherlock of book and movie fame, but Sherloc, the rock scanning instrument on the Mars Perseverance Rover. Here is Sananda Sharma, the postdoctoral fellow and part of the Mars 2020 team at the Jet Propulsion Laboratory, to explain how Sherloc works and some of the amazing things it has done since landing on Mars on February the 18th, 2021.
Sherloc it's an acronym like many things that are here at JPL. It stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. And it's one of the 7 scientific instruments that's on the Perseverance Rover, and it's on the rover arms. And that arm does a lot of work. So it does our proximity science, meaning it observes rocks really up close, where some of the instruments are remote science instruments and they work from a little bit further away from a rock surface. So Sherloc is a deep UV, Raman, and fluorescence spectrometer with 2 different imaging systems, and one of them is called Watson, so Sherloc and Watson. When I said that it observes rock surfaces up close, I mean literally imagine the height of a credit card. That's how far we are from rock surfaces, so 48 millimeters away. And Sherloc gives multiple different types of information. So it gives image information and spectra. And spectra are basically signals that result from light interaction with a rock surface. And the light that we use is a special type of laser that you can think of as sort of a fancy black light. And it helps us see things that are in the rock that would be otherwise invisible to us. So the images that we take with Sherloc's 2 cameras, that provides visual context for where the laser hit. So when Sherloc studies a rock surface, it shoots its laser in a pattern across an area that's about the size of a pencil eraser, so quite small, and it lights up different components in the rock, including chemicals, minerals, and organic matter. And organic matter, or organics as people sometimes say, that is made up of the element carbon. That's along with other elements like hydrogen, nitrogen, and oxygen. And organics are super interesting to us because they're commonly called the building blocks of life. So all life as we know it is made up of organics, but organics importantly can also be made through other chemical processes, such as through water-rock interactions, and it's also found in interstellar dust. So with this 2 types of spectroscopy, Sherloc helps the rover detect different spatial patterns of organics and minerals and give important views of samples that we're seeing with minimal alteration. So we go up to a rock, the only things that we would do is either blow dust off the surface or abrade, meaning remove the top layer with a particular drill bit that we have, and then just observe the rock in place, so no busting it up or anything like that. All of the instruments that we have work together on the rover quite elegantly, and across all of them we can get chemical, mineralogical, elemental, textural, color, and stratigraphic data to catalog all the most detailed information possible across spatial scales and across observational axes. So Sherloc, as you can see, is on like the finer scales here. So we work on the centimeter all the way down past the millimeter scale. So we have some of the closest views that we've had to date of rocks on the Martian surface. And Sherloc is the first of its kind instrument that's operating on Mars, and it gives us especially important information about rocks that are, as they're found, to support the selection of samples for potential return to Earth. And that's one part of this mission that's particularly interesting. So previously, when we've gone to Mars, we're trying to get all the information that we can from the surface. And in this case, what we're doing is there's potential opportunity for us to return samples back to Earth for further study. And so what we want to do with the instruments on the rover is collect all the data possible so we can decide, make almost a priority list. We observe something here. Does that look like a sample we'd want to bring back to Earth and do further study on? If yes, collect. And that's something that Sherloc helps a lot with. So it's able to look at all those different components in a rock and figure out, are these, say, minerals that could preserve organic matter or potential signs of life really well? Then we definitely want to put that at the top of our list to return. So it helps with that sort of in situ, meaning in place, information gathering.
Perseverance has been on Mars for an amazing 2 years now and has changed the way that we look at Mars. Perseverance is investigating the Jezero crater, a region of Mars where the ancient environment may have been favorable for microbial life, and probing the Martian rocks for evidence of past life. Hopefully one day in the future, the samples that have been collected by Perseverance will be retrieved and returned to Earth for further study. That will truly be an even more amazing feat. Thank you for joining me. Remember each Tuesday to join David Denault for America's Return to Space, and join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends, and follow us on Facebook. Join us each week for news and information on America in Space.